Alright, now look at example 1b under spherical shape and we solve using implicit differentiation. Right? A spherical balloon is being inflated at a rate of 12 cm³ per second. Find the rate of change of the surface area when the radius is 3 cm. Right? From the given question, we write into mathematical expression. Okay. Step 1. Draw an appropriate diagram and label the quantities relevant to the problem. Right? The given shape is sphere. Right? So we draw a sphere with radius r. Right? Step 2. Put a suitable variable based on the given unit. Right? The given unit here is cm³ per second. Okay, and the word used here is inflated. Right? Inflated means blow up. Okay, means that the volume will increase. Right? So from the given unit cm³ per second here, okay, we can write variable dv over dt, means d volume over d time, because cm³ means volume and over s second means time. So we can write dv over dt equals to 12. We put positive here because the word used here is inflated. Inflated means blow up, means volume increase. So we put positive sign here, right? So dv over dt equals to positive 12 cm³ per second, right? And then step 3, write the information into mathematical expression, alright? So the question is find the rate of change. Rate here means based on time, okay? Find the rate of change of the surface area, okay? So we want to find surface area, okay? Rate of change of the surface area. So the symbol should be dA, A for surface area, over d time because of rate of change, and then equals to question mark because we want to find it, right? When r equals to 3 cm, right? So this is the given question and we write into mathematical expression, right? Now we continue with solution. Alright. So first step, when we solve, okay, we can continue step 4. Alright. Write an appropriate formula based on the given shape. Right? The given shape is sphere. Right? And we have the value of dv over d time. Okay, d volume over d time. So means that we can start with formula volume of sphere. Right? Volume of sphere equals to 4 over 3 pi r cubed. Right? And after that, if we want to solve using implicit differentiation, so we differentiate both sides implicitly with respect to time. Right? So we differentiate v with respect to time, so we have dv over dt. Right? 4 over 3 pi here is constant, means that we still put and then we differentiate r cubed. When we differentiate r cubed, it becomes 3r squared. And 3 from here, we can simplify with denominator 3 here. Alright? So, after we differentiate, so we have d volume over d time equals to 4 pi r squared. And then we have dr over dt here. Because we differentiate with respect to time. Alright? Okay, and then step 6, replace the given value into the appropriate variable. Right? So means that we replace dv over dt equals to the given value is 12. And then 4 pi r equals to 3. Right? We replace dv over dt equals to 12. We replace r equals to 3, alright? Okay, you must substitute the value of the given variable after you differentiate, alright? Never substitute the value of r here into formula volume here because we still not differentiate. Okay, so we still not get the symbol dv over dt. So make sure you substitute after you differentiate, right? Okay, and then step 7, solve for the wanted rate of change and put a suitable unit for the final answer. Alright, so we write dr over dt as a subject. So we have 12 over 36 pi here. And after we simplify, we have 1 over 3 pi. Okay, so now we have dr over dt. Okay, but we look back the question. Okay, the question asking about dA over dt. Okay, means that we still not get the final answer. Alright, so we need to find dA over dt. Okay, because here we get dr over dt, not dA over dt. Alright. Alright. From the previous slide, we stop until dr over dt equals to 1 over 3 pi. Right? But the question asking about how to find dA dt, okay, not dr dt. Okay, means that we still not finish our calculation. Alright? So how to get dA over dt? Right? So we continue from under step solution. Okay, we continue from step number 4. Okay, we repeat step number 4. Write an appropriate formula based on the given shape. Okay, so now we want to find dA dt. Alright, so means that we continue with formula A. Okay, A means surface area and the given shape is sphere, means we continue with formula surface area of sphere, right? And surface area of sphere equals to 4 pi r squared, right? Okay, after that, we continue with step 5, differentiate both sides implicitly with respect to time if we want to solve using implicit differentiation, right? So from here, we differentiate A with respect to time, so we have dA over dt equals to, okay, we differentiate 4 pi r squared, so we have 8 pi r, and then at the back should have dr over dt because we differentiate with respect to time. Alright? Okay, after that, step 6, we replace the given value into the appropriate variable. Alright? Okay, so we replace dr over dt equals to 1 over 3 pi. We replace here. Alright? And then we replace r equals to 3 here, from here. Okay? And then we can simplify 3 pi here and 3 pi from denominator. Right? And then solve for the wanted rate of change and put a suitable unit for the final answer. Alright? So after we simplify, we have dA over dt equals to 8. And then we put a suitable unit for the final answer. 8 cm squared per second because surface area means cm squared and then time means second. Okay, so that's why we have dA over dt equals to 8 cm squared per second. Alright, and then when we check from the question, okay, so we have dA over dt here equals to question mark. So now we complete the answer. Okay, now our dA over dt equals to 8 cm squared per second. Okay, So therefore, the surface area is increasing at a rate of 8 cm squared per second. Increasing here because the final answer, we have positive value here. Alright? Alright. Now, we repeat the same example, but this time we use chain rule. Alright? Okay, step 1. We write the question in terms of mathematical expression. Okay, so draw an appropriate diagram. So we draw the diagram is sphere with radius r. And then step 2, we put a suitable variable based on the given unit. The given unit is cm cube per second. And then the word is inflated. So means we have dv over dt equals to positive 12 cm cube per second. And then write the information into mathematical expression. So we want to find the rate of change of surface area. So dA over dt equals to question mark when r equals to 3 cm. This is what we get from the given question, right? We write in terms of mathematical expression, right? And then we can start the solution, right? So step 4, write an appropriate formula based on the given shape. Okay, the given shape is sphere, and then we are given dv over dt, so we start with volume of sphere, right? Volume of sphere equals to 4 over 3 pi r cube, right? And step 5, we can use either implicit differentiation or chain rule, right? We done discuss using implicit differentiation. So now we discuss how to use chain rule to solve this example, right? So now we differentiate with respect to r, right? If we want to use chain rule. If we want to use implicit differentiation, we differentiate with respect to t, time. But if we want to use chain rule, we differentiate with respect to the given variable. Means that we differentiate with respect to r here, right? So we have dv over dr after we differentiate with respect to r equals to 4 pi r squared, and then at the back actually we have dr over dr, but dr over dr equals to 1, so no need to write, right? Right, after we differentiate with respect to r, we replace the given value into the appropriate variable, right? So we replace 3, okay, into variable r, right, from here, okay, right, but we cannot replace dv over dr equals to 12 because 12 here is the value for dv over dt, not dv over dr, right? Okay, and then solve for the wanted rate of change and put a suitable unit, right? So after we simplify, we have dv over dr, okay, equals to 36 pi. But actually, this is not the final answer, so no need to write a suitable unit, right? Because the question asking about how to find dA over dt, not dv over dr. Okay, it means that we still not complete our solution. Alright? Alright, from the previous slide, we stop until here. dv over dr equals to 36 pi. And when we compare to the given question, we want to find dA over dt, not dv over dr. Means that we still not complete our solution. Alright? So we continue with step under solution. We repeat the step. Okay. Just now in step 4 under solution, we use formula of volume of sphere. Okay. But now we continue with formula surface area of sphere. Right. So the surface area of sphere equals to 4 pi r squared. And after we identify the suitable formula, we differentiate with respect to r if we want to differentiate using chain rule. If we want to differentiate using implicit differentiation, we differentiate with respect to time, right? Okay, so after we differentiate with respect to r, we have dA over dr equals to 8 pi r. Okay, and then at the back actually has dr over dr, but dr over dr equals to 1, so no need to write. So we just write dA over dr equals to 8 pi r. Alright, and then we replace the given value into the appropriate variable. So our variable now is r. So we replace r equals to 3 from here. Okay, and then we simplify, so we have 24 pi. But this is the value for dA over dr, not dA over dt. So means that we still not complete our solution, right? So using chain rule, we can create formula for dA over dt, right? So our dA over dt using chain rule equals to, the first numerator should be dA. The last denominator should be dt, right? So we have dA over dr, so we can write dA over dr. So after we write dA over dr, okay, the next derivative should be dr over dv, and dr should be on the top. Okay, so from here we have dv over dr. Okay, but now we want to write dr over dv. Right, and then times, if we have denominator dv here, so the next derivative we need to start with dv on the numerator. Alright, looks like we can simplify dr dr and dv dv here. Alright, okay, this is called chain rule formula. Right, and after that we solve the wanted rate of change and put a suitable unit for the final answer. Alright, so we have dA over dt, and then we substitute dA dr. Okay, dA dr equals to 24 over pi. Alright, and then from here, alright, we have dV over dr equals to 36 pi. Okay, now we want to write dr over dV. So means that we just take a reciprocal value. So we have 1 over 36 pi for dr over dV. Why 1 over? Because actually dV over dr here equals to 36 pi over 1. So when we exchange numerator and denominator, so it becomes dr over dV equals to 1 over 36 pi. So we can substitute here. Right? So our dr over dV equals to 1 over 36 pi. Okay, and then we replace dV over dt equals to 12 here. Alright, and after that we simplify, so we have 8. Okay, and we put a suitable unit for the final answer, cm squared per second, because dA, A means surface area, cm squared over time here means second. So when we compare to the given question, we want to find dA over dt. So now we get dA over dt. Means that this is the final answer, right? And then we can write the surface area is increasing at a rate of 8 cm squared per second. And we have positive value here. So that's why the word is increasing, right? Coming up next, conical shape examples. Thank you for watching. Stay tuned. Bye. Assalamualaikum.